Problem 29, a change of variables problem. So we have this integral right here we need to evaluate, and we're integrating over the region in the xy plane, the parallelogram with these four vertices here. Let's just draw a quick picture in the xy plane. So we know what we're dealing with here. So we have a point at 1, 2. We have a point at 3, 4. We have a point at 4, 3. And we have a point at 6, 5. Okay, so this is the region R that we're integrating over. And furthermore, we are told what the what change of variables to use here. U is x minus y. V is x minus 3y. Our first task is to write x and y in terms of u and v. So in order to do that, let's figure out what's going on here. So I write u is equal to x minus y and v is equal to x minus 3y. If we subtract this v equation from the u equation, on the left we obtain u minus v. On the right we have x minus x is 0. Negative y plus 3y is 2y. And so we see here that y is equal to u minus v, all of that over 2. Okay, so that gives us y in terms of u and v. We should also be able to obtain x in terms of u and v. So if we have u is equal to x minus y, but y we just said here is u minus v over 2. Moving that to the other side, x is equal to u plus u minus v over 2. And so that looks like 3u minus v over 2 is our expression here for u. Okay, so we've part A is done. Part B, we need to calculate the Jacobian here. So how do we compute this? It's a 2 by 2 determinant. The first slot is the partial derivative to x with respect to u. It's 3/2. The second slot here is partial derivative to x with respect to v, negative 1/2. This third slot is the partial derivative of y with respect to u, 1/2, and then partial derivative of y with respect to v is negative 1/2. And so the Jacobian is this determinant, this times this, negative 3/4 minus this times this, so that would be plus 1/4 here, is going to be negative 1/2. Okay, so this is the Jacobian, but we should also know that when we go and apply the change of variables formula, we need to insert in a factor not of the Jacobian itself, but of the absolute value of the Jacobian, which is 1/2. Okay, so part A and B down. Next up is going to be part C. We need bounds on u and v. We need bounds on u and v. Okay, how do we go about determining bounds on u and v? Well, I think part of this, one thing that I want to think about here is what are these sides? What are these sides here? So the straight line segment from 1, 2 to 3, 4. This is a line that has equation y is equal to, so the slope here is 1. So y is equal to x. Y is equal to x plus 1 is an equation for this line. If we rearrange this, we end up with, I'm going to rearrange this to make this x minus y, because u is equal to x minus y. That's going to be becoming useful soon. So x minus y is equal to -1. The straight line segment from 4, 3 to 6, 5. So this has equation y is equal to x. The slope here is once again 1. Y is equal to x minus 1 here. And so this is going to be, rearrange this, write x in terms, sorry, write this as x minus y. X minus y is equal to +1. And so we can see here that this line is x minus y is -1. This line is x minus y is +1. So this gives us x minus y needs to be between -1 and +1. But then u is x minus y. So hey, take a look here. We just figure out bounds on u. Okay, let's do something similar for these two sides. 1, 2 to 4, 3. This is going to have equation here. Y is equal to, so the slope here is going to be 1/3 x. And let's see here, when x is 1, I think we need to tack on here plus 5/3. We'll do the trick. Let's make this look more like x minus 3y here. We multiply it through by 3. We have 3y is equal to x plus 5, or x minus 3y is equal to -5. And then the fourth side is the straight line segment from 3, 4 to 6, 5. And so this is going to have equation y is equal to 1/3 x. The slope of this line is going to once again be 1/3. Plus, let's see here, when x is 3, 1/3 times 3 will be 1. I think we need to tack on 3 here. Multiplying through by 3 gives us 3y is equal to x plus 9. And rearranging here would give us x minus 3y is equal to -9. So these two sides are x minus 3y is -5, x minus 3y is -9 here. We see here that x minus 3y needs to be between -5, -5 is bigger, -9 is smaller, but x minus 3y is v. There. V is from -9 to -5. So what does our double integral become? It's the integral v runs from -9 to -5. U runs from -1 to 1. I'm just stealing these bounds here. The integrand is x minus y, but x minus y is u. The u dv, need one more thing here. We need to insert in the factor of the Jacobian, is 1/2. Okay, so this is the setup here for the double integral. You should be able to, without too much difficulty, carry out this integration here. I'm going to omit the details.